All right, so we're going to find all actual roots, real and imaginary. So in order to find actual, we first have to list out the possible. So that would be the factors of 2, which would be plus or minus 2 and 1, and the factors of 6, which would be plus or minus 6, 1, 2, and 3. And we always use P on top of Q to list out all the factors. So that would be plus or minus 6 over 2 and 6 over 1. I'm just going to put plus or minus 1s. This is plus or minus for all of them. Plus or minus 1 over 2 and 1 over 1. 2 over 2 and 2 over 1. 3 over 2 and 3 over 1. And again, those are all plus or minus. And if we simplify these, we get plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 1. This is 1 again, plus or minus 2, plus or minus 3/2, and plus or minus 3, which we already have. So these are our possible roots. And if it asks for just possible, we would be done. But it asks for actual. So we've talked about before how you can plug these in using synthetic division and see if you ever get a remainder of 0. However, what you can also do instead is plug these in using synthetic division, and once you do get an answer of 0, you're going to get a new polynomial that's now a cubic, because it was a quartic, so now we can try to change it down into a cubic. And then when we change it down into a cubic, we can actually find another divisor and divide by that and change it into a quadratic, which then we could solve. So that'd be a lot easier than plugging in every single one of these and seeing if these works, because we would have to do that and find 4 roots. And we also wouldn't get any imaginary roots, which is the big issue there. These are only the possible real roots. We also need to find the imaginary. So we're going to pick any one of these. We're going to pick it at random. And first I'm going to pick positive 3. And I'll just go ahead and tell you that does not work. If we do synthetic division, it does not work. It doesn't give us a remainder. So to save time, I'm not going to go through that. I'm going to pick one that does work. I'm going to pick -1. And I'm going to set up my synthetic division using the coefficients 2, -3, 0, because here we have an x squared that's missing. So we have to use a 0 for that. Then -1 and then -6. And then we need to do our synthetic division. -2, add down, -5, add down, 5, add down, 6, add down, and we get a remainder of 0. So now we have a new polynomial that's cubic, so that would be 2x cubed, because it has to be 1 less than this, minus 5x squared plus 5x minus 6. Now, if we have this new term, that's now, we could rewrite this as x plus 1, since our root would be -1, times 2x cubed minus 5x squared plus 5x minus 6. That's the same thing as this, just in factored form. Now, the same possible roots applies to this. So now we can pick another root, and again, I'm going to pick one that I know that works, would be positive 2. So I'm going to pick positive 2, and I'm going to use this as my new polynomial. And the reason we're going to use this instead of the original one is because this is a cubic, and we can now knock it down to a quadratic. So, synthetic division. Oops, I shouldn't have written my terms. It'll still work. Bring down the 2, 4, add down, -2, add down, 6, add down, and again we get a remainder of 0. So that is also a root. And now this was a cubic. Now we can knock it down to a quadratic. So we get 2x squared minus 1x plus 3. Now our original polynomial we can write as now x plus 1 times this would be x minus 2. And this is now a quadratic. And now we have a root of -1, a root of positive 2, and we can use the quadratic formula to find the 2 roots here. So quadratic formula would be negative b plus or minus the square root of b squared minus 4ac all over 2a, which turns out to be 1 plus or minus the square root of negative 23 over 4, which we would change to 1 plus or minus I radical 23. And we would also simplify this if possible and simplify any outside things, but that does not work. So this would be our other two roots to imaginary. So we also have 1 plus or minus I radical 23 over 4. And this would be all four roots, 2 real, 2 imaginary. And that would be your final answer.